Hey guys, I just thought I would make a quick solutions video to these three worksheets from the evolution unit. Hopefully, if they didn't make sense before, they will make sense after. So here's the two kind of equations that we can use for Hardy-Weinberg, which is, the idea that if we know, I guess this is the idea that this is always true, where P is the frequency of the dominant allele, Q is the frequency of the recessive allele. This value would represent the homozygous dominant organisms in a population, and this would be the heterozygotes, and this would be the homozygous recessive. And they will always add up to 1, but I don't think you'll find that that actually matters when we're doing the math. Okay, so first one, in a certain population, and I did make this question up. No, this is not a real trait. But googly eyes is dominant over normal eyes. If 45% of the alleles are capital G for googly eyes and 55% are lowercase g for normal eyes, what percent of the following, or what are the percentages of the following in the population? So we just have to use this, what we just kind of talked about. So homozygous googly would be P squared. So we have to figure out what is P. Okay, so it says 45% of the alleles are G. That's the dominant allele. So this would be 0.45 squared, which is 20.25, or like that. Or if you would like to write it as a percentage, it doesn't make too big of a difference. But just realize that when you're doing the math, it has to be not the percentage form, but the decimal form. Okay. So normal-eyed people would be, that's the recessive trait. It's got to be Q squared, so that would be 0.55 squared, which is 0.3025, or 30.25%. And heterozygous googly-eyed people would be 2 times 0.45 times 0.55, which is 0.495, or 49.5%. And so when this part where they all add up to 1 really comes to play at the end as a good way to kind of double check yourself, right? So basically 20 plus basically 30 plus basically 50, that adds up to 100, so that makes sense. Or if I did 0.2 plus 0.3 plus 0.5, that adds up to 100. So we probably did it right. The double checking checks out. All right. In a certain population, widow's peak is dominant over straight hairline. What is the percent of each allele if 70% of the population has a straight hairline? So this time I gave you Q squared. Remember, Q squared is the frequency with the recessive trait. Okay. So that's basically saying this W is Q, and Q squared is 0.7. So in math, when we have our variable squared, remember to get rid of the squared, you square root. So Q is the square root of 0.7, which is 0.84. And finding the other allele, people tried to make more difficult. I had several people ask for help on this one. And just remember, we only can use the Hardy-Weinberg law when there's only 2 alleles. Okay? So if the frequency of this one's 0.84, this one has to be 0.16. Okay? So think about it. If we add those together, they have to add up to 1. Okay? Because 100% of the alleles are just shared between these 2 alleles. Okay? I'm probably not going to write all the rest of the answers out. I just wanted to do especially the math ones because they're a little bit harder to think about. All right, so Hardy-Weinberg law says allele frequencies won't change assuming certain conditions are met. What are these conditions? So these are any condition that would kind of make change in a population less likely. Okay, so we had, I'm actually just going to flash the notes up from before. Here's our list. Mating is random. Okay, it's not like one male is mating with all the females. It's just random. Okay, there's no mutations. There's no new changes being introduced into your population. There's no migration in or out. You're not gaining new organisms with new alleles to change the gene pool. Population is large. Genetic drift is really going to affect a small population. And so if we have a large population, random chance is just going to be less of a factor. And 5 is basically that there's no natural selection, that all genes make everybody equally fit. No organisms are selected over others. I really like this question. In normal biology, I would define evolution as change over generations. This year we say it's a change in allele frequencies. Why are these descriptions not in conflict? And then I even said, looking for some thought put into this one. I had a lot of people say they're not in conflict because they're both true. Yeah, that is not really showing me that you put some thought into this one. So a really kind of good way to think about this is like small scale. This is kind of what is causing the traits to change. And then if we have enough changes in allele frequencies, we can see a noticeable change over generations. And so this is kind of like the small scale changes that can lead to big scale, like noticeable changes. So I kind of think of this as cause and this is the effect, right? All right, so there was worksheet 1. Worksheet 2. Why has Lamarck's theory about evolution been rejected? He said that acquired characteristics were passed on, but only your genes that you pass on in the egg and sperm determine the traits of your offspring. So, you can make as many changes to yourself as you want, but it's only your genetics that you already have when you're born that can be passed on to your offspring. What is natural selection and how does it result in a changing population? Key word on this is the selection. Okay, so the organisms that are the most fit are quote unquote selected, meaning they get to reproduce. Their genes get passed on more often because they are going to have more babies than the ones that are not selected. So it results in a changing population because the organisms that are selected get to pass their genes on, and so over time their genes are going to become more common in that population. All right, in biology, what does it mean to say an organism has high fitness or is very fit? We would say high fitness, if you really wanted to zero it in, you would say it is able to reproduce, like to make the most offspring. The most fit organism of a population is the one with the most babies. We usually say also to help it survive, but you could pin it down just to reproduction if you wanted to. But high fitness means they're very able to survive and reproduce. All right, describe and differentiate between species and subspecies. How are they the same? How are they different? They're the same because subspecies are members of the same species. Okay, so they could all interbreed with each other. They could all kind of, share a gene pool. But how are they different? A subspecies has a certain set of traits that sets them apart. So remember we had subspecies included things like breeds, varieties, strains. Some biology textbooks say race, not all. That's kind of a charged subject. But yeah, so the idea is they have some differences from each other, but they are still the same species. All right, this one I had some really wild answers on. Let's say we discover a new continent. There are no predator species on that continent. A boat docks on the continent that happens to have 4 black cats on board. They get off and wander into the forest. In 30 years, cats have taken over the whole continent. What are these cats probably going to look like? I would say they're probably mostly black cats. Okay, the only 4 cats that started this whole population were black cats. I would say these are probably going to be black cats. Okay, how is this different from the whole species of cats on Earth? Yes, there's black cats on the rest of the planet, but I wouldn't say they're the most common. There's lots of colors and styles of cats on Earth, right? And this would be a good example of the founder effect. Okay, the idea that if a small group starts a new population, the new population is going to have just access to those genes that small group brought. I had a lot of people talk about how the cats were going to change and camouflage and get big and have big teeth. In 30 years, that's not really enough generations to make that kind of big scale change in a species in the wild. But I kind of understood what you were going for, but it was not nearly long enough amount of time for that to happen. All right, last one. This again is a why question. Why would two species converge and develop similar traits? Well, because they must be doing similar jobs, and so the same kinds of traits are going to give them advantages and be selected for. So since they're doing the same job, the same traits are going to be selected for, so they're going to become more similar and have whatever traits are the best at doing that job. Why did one species diversify and develop into at least 10? Because they were in a new place with lots of empty niches, right? So they diversified to fill all the available niches and eat all of the available food sources, and because they had lots of time and lots of available food sources. What's the difference between gradualism and punctuated equilibrium? Gradualism is very, very slow changes of evolution. Punctuated equilibrium is the very fast, more rapid version of evolution. So the difference is their pace, their speed. And then it's why. Why would one happen instead of the other? Okay, think about this. If an environment is constant, okay, not really changing very much, the climate's not changing, the food availability is not changing, the amount of predators is not changing, there's not really any pressure on a species to change, right? So still, more are going to be born than survive and reproduce, so you're going to have some change in allele frequency happening, but it's slow, okay? But let's say meteor strikes, like go back to dinosaur days, a meteor hits the world, the climate changes, all of a sudden a large percentage of the plants die. There's a big pressure for a species to change, right? The species that were living are not going to be successful in this new environment. So evolution had to speed up because the environment had changed a lot in a very short amount of time. So the why is kind of their surroundings, their environment, and what it's doing. Okay, describe one essential factor that must be present for a species to separate and become two separate species. Looking for isolation here. And we had lots of kinds of isolation, but the one essential factor is that we do not have gene flow between two groups of a species. Okay, so, again, we talked about lots of ways they can be isolated from each other, but if I said the one essential factor, it's isolation, or you could say it a different way and say lack of gene flow between populations. Describe temporal isolation. This is also an interesting one. There's also a temporal isolation in the computer science world that I got a few people had that answer down for this question, which, remember, I try to write the notes so that they're at the right level and cover things the right way for this class. So Googling is great, but make sure that it's still relevant to biology. So temporal isolation is when they're isolated in time. Okay, so some members of the population are more active in the mornings and some are more active in the afternoons, and they just are mating with those other organisms that are active at the same time. Or a small part of, a population starts their mating season a week earlier, and some take their mating season a week later. And so again, they're only having gene flow between the ones who are active at the same time as they are. So they're isolated and restricting gene flow because of time. All right, last one. What term might we use to describe bison in North America and wildebeests in Africa? So these are different species, but they kind of have similar niches, right? So they're grazers. They would naturally have big herds, and they move around and follow the grasses. And the term for the different species was this one, ecological equivalence. And this is another one. I had a lot of you write convergent evolution on this one, and that would be kind of the process that keeps them the same, right? Because they're doing the same job, and so they're going to keep kind of similar adaptations to do that job, but that's the process. This is what we would call the species that are doing equivalent jobs in different ecosystems. Okay, so probably right before I put out the test, I'll put out a video like this of the review assignment. So hopefully some of you watch it. Bye, guys.